In this problem, we're given a Markov chain model with 4 different states, and we're given the force of transitions. This species is currently in state 0. We want to calculate the probability this species will be in state 2 10 years later. So in other words, what we want to find is 10 px and then 0, 2. So it's currently in state 0. It wants to end up in state 2 at the end of 10 years. Okay, so there's 2 ways to do this. Well, first, because we're looking in 10 years, our integral is going to go from 0 to 10. So we can either stay at state 0, and here we could just put the bar over because we can't go to state 0. We can't go from state 0 to another state and back. So if I were to draw this out, I could go from 0 to 1, 1 to 2, and 2 to 3. So I can never, if I leave state 0, I can never come back. That's why we're going to put the bar over. So to be more specific, so these are equivalent since I can never come back to state 0. And then I'm going to transition from state 0 to state 1 at time x plus t, or in, I guess, t years after. And then I'm going to stay, then I'm going to go from 1 to 2. So I'm going to transition from state 1 to 2, and that's going to take in 10 minus t years. So altogether, if I add it up, I should get 10 years. dt. Okay, the other way to do this is I'm still going to go from 0 to 10, but I can go from 0 to 1, and then 1 to 2, and then I'm just going to stay at state 2. And here, because if I leave state 2, I can never come back to it, I could just put the bar over. So either one is going to get us the right answer. So the next step is, let's find out all these pieces. Let's start off with the easy one. I'm going to start in state 0, end at state 0. That's just going to be e to the negative 0.03t. Now the force of transition from state 0 to state 1 is 0.03. And now 10 minus t p x plus t, and then going from 1 to 2. Well, this is obviously going to go from 0 to 10 minus t, the integral, because this is the limit, the upper limit. Now I'm going to hang out state 1 for some time. And then I'm going to transition from state 1 to state 2. And then once I reach state 2, I'm just going to stay there. Okay, so this one we have to be very careful. We don't have dt anymore. We want to represent this in terms of t. So we're going to integrate it with respect to s. And then once we integrate it, everything will be in terms of t. So staying at state 1, well, the force of transition out of state 1 is 0.05. So that's going to be e to the negative 0.05 s. Transitioning from state 1 to 2, the force is 0.05. And then staying at state 2, well, to exit, it's 0.06. And then we're just going to have 10 minus t minus s ds. And so now we just integrate it. We're going to treat the t as a constant here. So that's what that is. The next thing, so those are all the pieces for the first integral. So then you just all put it together and integrate from 0 to 10. Now for the second one, I'm going to need this one right here. So the probability, I start in state 0, end at state 1 in t years. So that's going to be the integral from 0 to t. And I'm going to stay state 0 for some time. And then I'm going to transition to state 1. And then I'm going to stay at state 1. So let's see. Okay. So staying at state 0, that's e to the negative 0.05 s. Sorry, 0.03 s. And then the force of transition from state 0 to 1, well, that's 0.03. And then staying at state 0, I'm sorry, staying at state 1, let's see. Well, if we go back, leaving state 1 is 0.05. So that's going to be 0.05, and then raise it to the t minus s ds. Okay, so then that's that probability starting at state 0 going to state 1 after t years. The next thing is a force of transition from state 1 to state 2. That's a 0.05. And then we want to find the probability that we'll start in state 2, end at state 2 for 10 minus t years. So we'll be looking at the force of transition exiting state 2, which is the 0.06. So that's this guy right here. And we're going to do that for 10 minus t. So we would put everything together, and for both integrals, the final answer will be 0.047124.